the next and the last talk for this session today is going to be delivered by Dr. Judith Nyiraneza. Dr. Judith will be presenting the role of organic amendments in building the soil. Dr. Judith holds a bachelor's in science in agricultural science, a master's in soil and crop science, and a PhD in soil and environment. Dr. Nyiraneza research activities contribute to increasing the resiliency of agroecosystems. She developed a suite of soil regenerative management practices, such as nurse crops, summer and winter cover crops, conventional and alternative soil amendments, which enhance soil health and crop performance, and reduce nitrate leaching to groundwater. Dr. Nyiraneza also identified novel strategies to enhance phosphorus and nitrogen use efficiencies in potato crop systems. And Dr. Nyiraneza is leading a Pan-Canadian Living Laboratory project where scientists collaborate with growers to accelerate the adoption of environmentally friendly management practice. She was recently recognized as one of the 6 2023 influential women in Canadian agriculture, and she was also named a fellow of the Canadian Society of Soil Science in 2024. Join me in welcoming Dr. Judith. First one here is the laser. You can point the director to the screen. This moves forward and this moves backward. Okay.
Thank you, Rodrigo, for introduction. And thank you, everyone who is still here. I know last presentation, in small room, you are more likely to have 5 people maximum. So I appreciate you being here. So the results I'm going to present are really collaboration with many people from AFC Charlottetown and Fredericton, PI Potato Board, PI Department of Agriculture and Land, and Laval University. So we all know that when we talk about soil health, there is one single parameter that is considered as key parameters of soil health, and that is soil organic matter. We know all the benefits of soil organic matter. Soil organic matter basically controls all soil properties. So it does enhance the soil structure, the resistance to erosion or the holding water, but also to allow a better infiltration. If you have low soil organic matter, you cannot also have your water infiltrated in your soil profile. It does also increase the nutrient use efficiency, the recycling of your nutrient, but also the microbial activity. More importantly, when you have a high soil organic matter, you can also mitigate climate change, global warming, due to the CO2 increase in the atmosphere. So if you have high soil organic matter, you are basically building your soil, but also mitigating climate change, because the soil will hold more carbon than the carbon you have in the atmosphere and in the vegetation. So why organic amendments are important? When you consider, let's say you turn on your land a certain amount of carbon with your sorghum or alfalfa, basically a very small percentage of your carbon returned to the soil will end in soil organic carbon. Only 3 to 33% will actually end in building your soil organic carbon. So if you think about cover crop, we know the roots will contribute more to build your soil organic carbon. The retention, the carbon retention factors is going to be 10 to 15% for your cover crop. But when we talk of a well-decomposed manure, we are looking at 50% of your carbon you apply with manure will actually be transferred in your soil organic carbon. But we are considering dry matter basis. So if you apply your sorghum a certain amount, you have to calculate the dry matter, so you consider the moisture content. So that is based on the dry matter biomass. So what if you don't have how do I go back? This one? I went too quickly. So what if you don't have organic amendment? If you don't have organic amendment, it does not mean that your organic amendment will build your soil organic matter quickly, that you just have to aim for that. Some people, they don't have organic amendment. Cover crop, so we know also they regenerate the soil. So basically what people tend to ask me, what is the best way to accelerate this building our soil? The key is to combine multiple regenerative soil management practices. So this is a slide from my colleagues in Quebec. And what they did, basically, they did a simulation of changes in your soil organic matter over 100 years. And they are in a clay loam soils, which is above 40% of soil organic matter, and they're in a rotation of corn, soybean. So the bottom line is showing basically business as usual. So you are basically rotating your soybean and corn, nothing else. But you can also, in this system, have a non-till system. You can add animal manure. You can add winter wheat. You can add nurse crop in your corn. You can also add, after your winter wheat, you can also add winter cover crop. So all what you can see here, this is really a slide I really like most. You can see there is an additive, you add a non-till, you do an intercrop in your corn, you add manure, you add a winter wheat, and then you can have cover crop after winter wheat. So you have an addition or a cumulative effect on your management practices to build your soil. So, and that's why we will see with my results I will present, a short time study, you really don't see the difference. But it's like investing in your stock market. If you wait for a long time, maybe we see profit. So this is showing that combining multiple management practices in the long run will play a good role. But we cannot imagine also that every single soil is going to behave like this. This is a clay loam with soil organic matter above 4.5. And if you are in a different soil with a different management practices, it may behave differently, but the bottom line is combining multiple management practices will help to build your soil. So I'm going to talk about two studies. We're gonna share preliminary results. The first study is comparing a full season cover crop with and without manure. And the second study, we will see the role of willow chip in building the soil. So our first study is in Harrington Research Farm. We basically have these 72 plots, and we have 8 treatments where we are comparing different cover crops. These different cover crops, we really consult with Steve Watts and Ryan Barrett. We really wanted to represent what several growers are testing in their farm. So we have cover crop which are based on legumes only. We have also cover crop that are based on grasses or mixing legumes with grasses. We have a 2-way mixture, we have a 3-way mixture. And we also included a bare soil with no cover crop. And this study was initiated in 2017. So we are now, after 6 years, we are coming to see if there is any change in soil. This is a 3-year potato rotation. So potato is grown once every 3 years. And manure is applied the first year we are growing cover crops. So manure is applied like 2 years ahead of potato, once every 3 years. So this is a picture showing the manure we apply is really not that much. It's 20 metric ton per hectare. This is on wet basis. And as I said, once every 3 years. I'm not going to present 9 treatment, that will be too much, so I'm focusing on 4. So the first rotation system, we have barley underseeded with annual ryegrass. Then the second year we come with either pearl millet or sorghum Sudan grass. So that means every single summer we are plowing the land. The third treatment is barley underseeded with red clover, then red clover in second year. And the other one, we have a 3-way mixture where I have ultra grass, brome grass, and common veg mixed together. So this is how the plants look like what happened? Okay, got it. So this is how the plants look like when we have a 3-way mixture. So your common veg, because it's not a perennial, it's really growing nicely in the first summer, then it's going to die with the cold. So the second year in this 3-way mixture, you're going to have more ultra grass and brome grass, and then you have sorghum and pearl millet for the other treatment. So we send our sample to peer analytical lab to focus on what they call the basic soil health package. That is looking on soil respiration. Soil respiration basically is showing you the activity of your microbial biomass by analyzing the carbon dioxide. And the aggregate stability is the resistance to your aggregate when you have like a storm, to see how they resist to disintegration with rain. And active carbon is showing you that easily available carbon source for your soil microbe, because we know the soil organic matter takes time to show the differences. And the carbon stock was done at a depth of 0 to 30 centimeter depth. So when we compare our rotation system, barley with red clover, or sorghum Sudan grass, or pearl millet, or 3-way mixture, for those carbon stock, soil respiration, active carbon, no differences. And it's not surprising, 6 years is not enough to detect the differences, but we did see differences on soil aggregate stability. So our pearl millet and sorghum Sudan grass were showing higher aggregate stability than the rotation that included red clover or the 3-way mixture. And for the potato marketable yield, so this is in 2024, but we did see the same trend in the first cycle. As I said, we started in 2017. Pearl millet, for some reason, is showing ability to boost potato yield. Probably is maybe controlling disease, root lesion and nematode. But it's very interesting to follow this trial to see what will happen. So pearl millet was comparable to the 3-way mixture, and red clover and sorghum Sudan grass were associated with lower yield. Interestingly, even if we don't see differences when we compare applying manure versus no manure, but we have a very interesting trend we did not see with cover crop. So we see that there is improved soil health with manure. So we can see the carbon stock increased 6% with manure. The carbon specialist in Fredericton was telling me this is a big increase in terms of carbon stock. He was saying that he was surprised to see this. Soil respiration was increased by 13% with manure, and the active carbon by 11%. So after 12 years, if we keep with this study, I expect to see significant difference with manure. The second study is evaluating the willow chip as alternative organic amendment. So we all know the benefit of willow shrubs. They are grown on marginal land along the river banks. They mitigate the erosion, they retain nutrients, they store carbon, and they grow quickly, specifically when you cut them. So there is like every 3 years they cut them, and that's why you stimulate the root growth. So because we have to cut them anyway, so I don't want anyone to work from this room saying, I'm gonna cut my forest to fertilize my land. This is not the message I'm giving, but with willow shrubs, it's possible because you can use them for food or biochar or animal bedding, but what if we use them as organic amendment? My colleague Yifang was leading this project and I was the co-lead. His main idea was to see, after potato harvest, because we leave behind high soil nitrate, if we apply willow chip, because they have a high carbon to nitrogen ratio, it can probably tie up that nitrate and preventing it from leaching to groundwater. And I was helping him then to analyze what happened with the soil, but the idea was really to mitigate nitrate leaching. So after potato harvest, so we applied the willow chip at increasing rate, so 20, 40, and 60 metric ton, that is wet basis. So the moisture content is around 52, carbon content 52, and carbon to nitrogen ratio 48. Basically, when you have a carbon to nitrogen ratio above 20 to 25, your microbe to decompose that product, it's gonna compete taking soil nitrogen to decompose it, because what is lacking here is the nitrogen source. So the willow chip was applied on the soil surface and was raked and disked in the topsoil, 0 to 15 centimeter depth. So spring 2019, we grew potato, and then 1 week after potato harvest, we applied the willow chip. The following spring, we have barley underseeded with red clover, and then the following spring, we have red clover. So we did install these anion exchange membranes you see here. So basically, the beauty of this ion exchange membrane, they are going to capture soil nitrate, and you're going to have them cumulative. So you leave them in fall, and you go in spring, you take them out, you bring them in the lab, you extract them, and you have the nitrate accumulated. The difference if you are doing soil sampling is you're going to sample today, there's a heavy rainfall today, you come back next week, that nitrate maybe has gone below the root zone. You don't see it, but ion exchange membrane, actually they show the dynamic of your soil mineral nitrogen over a certain time. So the following spring, as I said, we have a barley, and we did quantify the barley yield, and 12 months later, so 1 year later, after applying the willow shrub, we analyzed soil pH, aggregate stability, soil respiration, and potassium, and carbon and nitrogen content. So what we did see, aggregate stability, soil respiration, and potassium above 40 metric ton per hectare, we did see significant improvement of soil at that rate. Keeping in mind that this is 52% moisture content. So that is 48 dry matter. So if we have 40, you really don't have that much amount you are applying. So it seems like a 40 and 60 metric ton is a huge amount, but if you take away the moisture content, that is not high rate. So very good in building the aggregate stability and in stimulating soil microbial biomass. And we did also see that soil organic carbon and soil moisture retention were significantly higher at the rate above 40 metric ton per hectare. 0 and 20, not big difference, always comparable. You go above, then you see differences. So this is the anion exchange membranes. So this higher nitrate in the soil the first winter. So that's the winter following our willow chip application. With 0, no application, you have this soil nitrate. 20 metric ton, this soil nitrate. Then you have on your ion exchange membrane with higher level of willow chip, you have a very, very low amount of nitrate. So Yifan hypothesis was right. So once you apply those willow chip, they are going to immobilize your released soil nitrate from the soil. And when you don't have it, you have high level of soil nitrate. The good news is that happens only in the first winter. Seems like over winter, the following spring and summer, that willow chip get degraded and is not retaining soil nitrate in the following winter. And this is good news because if it does a good job in scavenging your residual soil nitrate after potato harvest, it means also in the following spring, it's going to compete with your cash crop, and you may have to bump up your nitrogen fertilizer to compensate. And we did see that with barley yield. So grain yield, or if we quantify nitrogen and carbon accumulation in our straw and grain, we noticed that at a higher rate of willow chip, yield were significantly lower, were depressed. The same for nitrogen accumulation or carbon. So this is very important. If someone is planning to apply willow chip and is aiming to have a cash crop in the following growing season, you may have to know that your yield may be depressed unless you increase your nitrogen rate. So for this preliminary result, we saw that manual application tended to increase soil health faster than full season cover crop. And this is 6 years later. So even 6 years, we don't see a big difference with cover crop. Sorghum, Sudan grass, and pearl millet, these increase soil aggregation. And pearl millet and the three-way full season cover crop mixture increase potato marketable yield. For the willow chip effect, the positive effect increased soil organic carbon, soil moisture retention, and available potassium, aggregate stability, soil microbial respiration, but we did see a short-term nitrogen mobilization. This can be seen as positive or negative depending on your objective. If your objective is to reduce a residual soil nitrate after potato harvest, it's a positive thing. If it's bumping up yield following your willow chip, it can be seen as negative goal. Negative yield suppression the following spring. So we recommend that if you want to boost your soil health and reduce soil nitrate leaching after potato, to grow a forage crop, you are not aiming to harvest, just grown to build your soil. Just to keep that in mind, that you may see yield suppression following willow chip. Thank you for your attention and for staying until the end. I will take any questions.
Questions to Dr. Judith? I think I can start. Yeah. So for spreading the willow chip, what kind of equipment could be used for that? And are you aware of any grower perhaps using some kind similar to that in their operation already?
Because we were dealing with small plots, we applied it by hand. But I would say any grower can use like the same equipment used for manure. No, I don't. I'm not aware. Yeah.
More questions, folks? It's a great research on the amongst all the other ones that we have already developed for PI, for potato growers, that helps us building soil health for the province. That's great project running here. And I was also happy to see some of the results that Yvonne has worked on her research, that Yvonne is my colleague now, worked under your supervision at her studies. So it was great. Thanks, Dr. Judith. Any questions, folks, before we finish this session here? Oh, okay. If not, I'll thank you, Dr. Judith, once again. I have a small gift for you, too.